Okay, let's dive into something that sounds a bit wild. Solar energy way up in Alaska. When you picture solar working best, you're probably thinking sunny California, Arizona. Right, not, Alaska with its long winters, tons of rain and snow, and those huge swings in daylight.
Yeah, exactly. On the surface, it seems like one of the toughest places imaginable for traditional solar panels. I mean, the limited sunlight in winter, that's a massive hurdle. Some places get hardly any useful sun for months.
Right. But the material we're looking at today shows something really interesting is happening. Solar is actually gaining traction there. And it's not just about sunlight anymore. We're going to unpack how they're exploring these hybrid systems that combine normal solar panels with tech that gets energy from rain.
That's the cutting edge stuff, yeah.
Yeah.
So, our mission here is to look at how these panels in Alaska might actually use both sun and rain, pulling out the key ideas from their research. It's a really cool example of pushing technology to work in extreme conditions.
Okay, so first off, it seems some of Alaska's challenges, surprisingly, can become advantages, like the cold and snow.
Right. It sounds backwards, but yeah.
Uh,
While winter darkness is definitely a limiter, in certain areas, the interior, for instance, you get conditions that are actually great for solar efficiency.
Mm.
Think low humidity, super clear cold air, and crucially intense reflection off the snow cover. That's called high albedo.
The albedo effect. So the snow bounces more light onto the panels.
Exactly. And there's this thing the sources called the spring bump. In spring and even summer, the cooler temperatures actually make the panels work more efficiently than they do in hot climates. Combine that with the snow reflection that might still be around, and panels can sometimes produce more than their official rating.
Wow. So there are actual examples.
Yeah, the Willow Solar Farm, way up near the Arctic Circle, is generating like 1.35 megawatt hours a year. It shows utility scale solar isn't totally out of the question, even in those conditions.
Okay, so cold boosts efficiency, snow helps reflect light. But what about the rain? You mentioned that. Especially coastal Alaska gets hammered with rain in the summer.
hmm And that's where this hybrid tech gets really interesting. We're talking about integrating solar cells with something called triboelectric nanogenerators, or TENS for short.
10 sinks. Okay, break that down.
Basically, they convert mechanical energy like the physical smack of a raindrop hitting the panel into electricity. The research talks about hybrid cells, standard silicon PV on the bottom, and then a Teng layer on top, often made of something durable like PTFE plastic.
So hang on. One single panel could be making power from the sun and from rain hitting it.
That's the idea. When it's cloudy and raining, solar output drops, obviously. But the Teng part could generate a bit of extra power, maybe up to 30 volts, according to the research, which helps bridge the gap. And they seem pretty tough. Tests showed they still work down to minus 30 Celsius. That cold resilience is key for Alaska.
Makes sense. Okay, beyond the fancy panel tech, just installing standard panels there must require some special tricks too.
Oh, absolutely. You can't just stick them up like you would down south. The sources really emphasize strategic installation. Forget shallow angles. In Alaska, you often need really steep tilts, maybe 60 degrees or even more.
Why so steep? Just for the low winter sun.
That's part of it, but it's also crucial for helping snow slide off naturally. Otherwise, it just piles up.
Yeah.
You also see panels mounted vertically on walls sometimes, especially in places like Anchorage, to handle snow and shading from buildings or terrain.
And just, keeping things from freezing solid.
Yeah, there's innovation there too. Things like special antifreeze gels for components or really smart controllers, MPTT controllers that optimize the power output constantly, which is vital for off-grid systems. And sometimes it's low-tech stuff too, like automated brushes or just designing things so snow doesn't build up easily.
Okay, let's talk money. What are we looking at for cost and payback for, say, a homeowner in Anchorage?
Right, the economics. It's a balancing act. A typical home system might run you like $10,000 to $30,000. It's a big investment. And the payback time is longer than in, say, Arizona, often 10 to 14 years.
Oof. So incentives must be pretty important.
Definitely. That 30% federal tax credit makes a huge difference in making it pencil out. But there's a catch sometimes, highlighted in the sources, how utilities handle excess power you send back to the grid. Some, like Chugach Electric, apparently only pay you back at a lower rate based on their fuel cost, not the full price you pay them for electricity.
So net metering isn't always one-to-one. That affects the payback calculation.
Big time. It means the main value is reducing your own bill, not necessarily making money selling power back.
So what do people actually using these systems say? Does it cover their needs?
Well, experiences vary, but the sources suggest many folks in Anchorage find solar can cover maybe 75% of their yearly energy use, which is pretty good, honestly. And this is important, you absolutely still need a backup power source, especially for those really dark winter months. No getting around that.
And the rain impact is real.
Oh, yeah. One source mentioned data from summer 2023 where heavy rainfall apparently cut solar output by something like 19% compared to the year before, which again circles back to why that hybrid rain harvesting tech, the Tenengs, could be so valuable eventually.
Right. So it's about clever tech, smart setup, and managing expectations.
Yeah.
What's next? Any future breakthroughs mentioned?
Yeah, they touch on a few promising areas, things like perovskite silicon tandem cells, that's a mouthful, aiming for much higher efficiency, over 30%, to grab more energy even when light is low. Also, ideas for district-level grids, combining solar, maybe those tangs, maybe wind, to create more stable power for remote communities, and even coatings for panels that help repel snow without blocking light. Little things that could make a difference in winter.
Okay, so wrapping this up, it sounds like hybrid systems could be key for Alaska's energy future, bridging those seasonal gaps. Smart adaptations boost efficiency, and that spring bump is a neat, unexpected plus.
Exactly. The economics are still tough, but costs are falling, incentives help, and the technology is evolving. It's becoming more feasible.
So here's something to think about. We've just talked about adapting solar tech for Alaska's unique mix, low light, rain, snow, extreme cold. Where else in the world do you think these kinds of hybrid solar and, let's call it, environmental harvesting technologies might be surprisingly useful? And what completely new challenges might pop up in those places?